Hi, this is Nathan Tintle. In this learning goal video, we'll talk about a theory-based approach for regression. We will use the heart rate and body temperature data set to talk about this learning goal. The null hypothesis says that there's no association between someone's heart rate and their body temperature. The alternative hypothesis says that there is an association. The slope of the best fit line is 2.44. You can do a simulation and find out that the p-value is fairly small, suggesting that in fact we have strong evidence of an association, essentially that the slope is greater than 0, between heart rate and body temperature. We've seen this simulated slope distribution before. It's a bell-shaped curve centered at 0. And this should hopefully set off some triggers in your mind that we probably have a theory-based approach for this test, and in fact we do. The theory-based method predicts a bell-shaped curve centered at 0. Now the theory-based approach doesn't use the correlation coefficient or the slope, but instead uses a t-statistic. And we've seen t-statistics before when you compare group means, specifically two group means, or when you do paired data analysis. And the t-statistic here, while the equation is more complicated, is interpreted in the same way. The t-statistic can actually be written as either a function of the sample correlation or the sample slope. And while we don't worry so much about computing it because we have technology that can compute this number for us, the t-statistic here is relatively easy to compute just using those values as we're showing on the page. The t-statistic on this data is 2.97, giving us a p-value of 0.0036, in this case identical to the one we obtained from simulation. Final word of caution, of course, this t-test, as we would call it, giving us a theory-based p-value for the slope or correlation, is only valid when certain validity conditions are met. We talk about those validity conditions in other learning goal videos.